Okay, in this video we want to get some practice converting between rectangular and polar coordinates. So in the last video I showed you how we can use the right triangle that we had. So if this is the origin and this is the point we're looking at, this is our r, this is our theta, this is your x and your y, and this is where they all come from. So we use the Pythagorean theorem to get that r equals the square root of x squared plus y squared. And we said that we can find theta by taking tangent inverse of y over x. Now, that will always give you an angle between negative pi over 2 and pi over 2, so you'll have to use reference angles to make sure you're in the right quadrant. And then we also had that cosine of theta equals x over r, and we had sine of theta equals y over r. And I said we'll use those to go the other way. So if we solve for x here, multiply both sides by r, we would have that x equals r cosine of theta. So if you had r and theta, you could find x by doing r cosine of theta. And similarly, we had sine of theta equals y over r, so y is equal to r sine of theta. Okay, so this says convert these two rectangular coordinates to polar. So this is, if we're starting with rectangular, we have x and y. So we want to find r and theta. So the first thing we're going to do is do r is equal to the square root of x squared plus y squared. So here it'd be the square root of 16 plus 16, since we're putting in 4 here and 4 here. So this would be the square root of 32, which if we reduce it, we could pull out a 4, so we'd have 4 square root of 2. So our r here is 4 square root of 2, and now we need to find our theta. So theta is going to be tangent inverse of 4 over 4. So it's tangent inverse of 1. And we want to look at this, and we know if we plot the point 4, 4, that we're in the first quadrant. So we want the angle in the first quadrant where the tangent is 1. So I pulled up our formula sheet here. And here, so we want to be in the first quadrant where y over x is equal to 1. And we see that happens at pi over 4. If we took square root of 2 over 2 divided by square root of 2 over 2, that would just be 1. So this happens at pi over 4. So that is our theta. Okay, so that's our answer. 4 square root of 2 and pi over 4. So what we're saying is for that same point that was 4, 4, this distance was 4 square root of 2, and this angle was pi over 4. Okay, here we have 2 square root of 3 comma 2. So our r, we're going to take the square root of 2 square root of 3 squared plus 2 squared. So 2 square root of 3 squared, we'd have 2 squared, which is 4, times square root of 3 squared, which is 3, so we'd have 12, plus 2 squared is 4, so we have the square root of 16, which is 4. So our r is 4. And for theta, we want to take tangent inverse of 2 over 2 square root of 3, which if we simplified this and rationalized it, we'd have tangent inverse of square root of 3 over 3. And again, this one happens to be in the first quadrant, so we would use our unit circle and say, okay, where would y over x be square root of 3 over 3? And that happens at pi over 6. So our theta is pi over 6. Okay, so that's when we went from rectangular to polar. And now we're going to go the other way, which I think is even a little bit easier. So it says convert these two polar equations to rectangular. So this is r and theta, and we're looking for x and y. Well, we have the formula that x equals r cosine of theta. So this would be, I didn't need a parenthesis there, 3 cosine of pi over 6. Well, if we use our unit circle, cosine of pi over 6 would be square root of 3 over 2. So we'd have 3 times square root of 3 over 2, and that would just be our x coordinate. Okay, so that's when we went from rectangular to polar. And now we're going to go the other way, which I think is even a little bit easier. So it says convert these two polar equations to rectangular. So this is r and theta, and we're looking for x and y. Well, we have the formula that x equals r cosine of theta. So this would be, I didn't need a parenthesis there, 3 cosine of pi over 6. Well, if we use our unit circle, cosine of pi over 6 would be square root of 3 over 2. So we'd have 3 times square root of 3 over 2. And that would just be our x coordinate. And our y would be r sine of pi over 6, which would be 3. And if we look at pi over 6, sine is 1/2. So this would just be 3/2. So in rectangular coordinates, this point is 3 square root of 3 over 2, comma 3/2. Okay, we're going to do the same thing here. This is our r, and this is our theta. So our x is going to be -2 cosine of 225. So we'll go to our unit circle, 225 degrees. Cosine is negative square root of 2 over 2. So -2, negative square root of 2 over 2. So the negatives cancel out, the 2's cancel out, we just get square root of 2. And y, we'd have -2 sine of 225 degrees. So we'll go to our unit circle, also negative square root of 2 over 2. So again, we get square root of 2. So this point in rectangular coordinates would be square root of 2, square root of 2.